So you want to know what really is going on inside the domestic dragon? It's the magic of the microbe. On the first day that we set up our digesters, we not only fill them with water all the way up, but with as many anaerobic microbes as we can. Now, technically, for each 1,000-liter digester, we generally try to put in at least 100 kilograms of some kind of fresh animal manure. In the city, because it's easier to find, we tend to use horse manure. But almost any animal will do. Cows, pigs, chickens, llamas, alpacas, goats, sheep, elephants, and hippos. Yes, we've started digesters on manure called zoo doo from the local zoo. And we've even started systems on my baby's washable diaper wastes. No, it's true. It provides a great incentive for dads to enthusiastically change the diapers. Honey, I'll change the diaper today. This inoculation only needs to be done once. Swallow. Although you can always add more manure anytime you like, because it always adds fresh microbes. And who are those microbes? Well, you've got 4 main groups of different tiny critters in these dragon stomachs. The first group are called hydrolytic bacteria. Their name means that they use water, hydro, to break apart food molecules, lytic. They are the first creatures to get to work in the process of biodigestion. They work underwater, but most can survive with or without air. After they've done their work, they make the molecules much, much smaller so that they're available to the second group of microbes called the acidogenic bacteria. Now, these critters take smaller energy-rich molecules and turn them into larger chain organic acids like butyric acid and propionic acid and all those other acids that you studied in organic chemistry. You're familiar with these creatures, even if you haven't taken organic chemistry, because they also exist in your stomach and are responsible for that horrible burn of acid reflux that you get when you overeat and, you too, start burping up incompletely digested parts of your last meal. They give you what we call heartburn. And they also produce a sick stench, which is why vomit smells the way it does. They also can mostly work with or without air. If that is as far as your digestion goes, you have a mess on your hands. And that's why your garbage pail stinks so bad and attracts flies and vermin. Byproducts of hydrolytic and acidogenic bacteria digestion is still filled with energy, but is broken down enough that lots of these other creatures are attracted to it. Fortunately, there are 2 other groups of microbes in the biodigester to take care of things before the rats and flies can even get a chance to know there's food about. The next step in the process is the great work of the acetogenic bacteria. Now, these critters take the bigger, stinkier acid molecules and break them down into much simpler carbonic acid, which is basically carbon dioxide dissolved in water, like the bubbles in your soda, and hydrogen and lots of acetic acid, aka vinegar. You know your digester has gotten to this stage when you smell a vinegary acid smell, but it doesn't make you feel sick or give you the gag reflex. But it still smells kind of sour. Even more fortunately, there's another final group of microbes in the tank, the mighty Methanogens. The Methanogens are very special. They aren't bacteria. They are what we now know as the Archaea, the most ancient life forms on the planet Earth. They were the first creatures here, and they will be the last. They are the Alpha and the Omega. They are our direct ancestors and that of all living things. They've always been with us, and once upon a time, they were the only creatures on Earth. And they now live inside us in our stomachs and intestines, and those of every living creature and in every nook and cranny of the modern Earth, wherever the sun don't shine, wherever there isn't any oxygen. The Archaea are the actual Methanogens, the microbes that generate the methane, but they do so in a constant and never-ending dance with their partner bacteria. Dance, boys, dance! You see, The Archaea are completely anaerobic microbes, and they ruled the Earth until their descendants, the cyanobacteria, a type of early algae, started making oxygen and poisoned them and drove them into the anaerobic or air-free spaces. But they never went away. And their specialty is to take carbon dioxide and hydrogen and acetic acid and turn these energy-rich molecules into biogas, into biomethane, or CH4, the simplest organic molecule with its single carbon and 4 hydrogen atoms. Methane is a tiny molecule, so it's lighter than air. When it burns, it turns into nothing more than carbon dioxide and water, as the oxygen combines with the carbon and with the hydrogen. So biogas burns clean and safe. No smoke, no soot, no pollution. And because the biomethane still contains about 30 to 40% carbon dioxide from that left over from the acetogens, biogas isn't explosive. After all, carbon dioxide is a flame extinguisher that is heavier than air and puts out fires. Good boy. While the methane rapidly rises up and spreads out to the point where it can no longer ignite. See? Only at the source of a biogas flame can you get ignition. There you go. Right where you want to cook or run a generator or light or heater or gas refrigerator. The 4 types of microbes work together efficiently to turn almost all organic wastes, with the exception of woody lignocellulose or straw-like materials, into a safe, clean fuel and a rich organic fertilizer. On the surfaces that we create in our artificial stomachs and intestines inside the digester, they form what is called a biofilm, a kind of surface scum layer like you find on your teeth in the morning before you brush them, which are like microscopic cities. You too? Yeah. In the biofilm, the microbes create symbiotic structures that efficiently divide the labor. Now imagine, if you will, a tiny city where in one district, like a warehouse district, food wastes are being delivered and broken down by the hydrolytic workers into smaller molecules that are then shipped or trucked over to the acidogenic district filled with vats, test tubes, where they get turned into seething green and yellow acids. And then you can imagine them being piped over to the acetogenic district with its big fizzy fermenting tanks and wine and vinegar barrels where they are turned into acetic acid and bubbles of fizzy carbon dioxide and hydrogen. Finally, these swirl through glass tubes into the methanogenic district, where our most ancient relatives, as different from other bacteria genetically as we are, according to recent DNA analysis, carefully take apart the vinegar and combine it with the CO2 and hydrogen to make bubbles of dancing fart gas. Hoppity-poppity bubbles of methane that rise up through the watery world of the digester tank and collect in the smoke-free chimneys leading to the gas valve. The entire process happens each and every day and night, continuously, in a process that never sleeps. Sorry, Charlie. Biogas is a form of solar energy that will never run out because it is solar energy that was trapped through photosynthesis into plants, eaten by animals, shipped to our human cities, whose uneaten or undigested parts we have traditionally, simply but tragically, thrown away. What are you doing? Incompletely broken down, creating bad odors that make you sick and attract disease-carrying rats and insects and pollute the air and water. Open up. There. With biodigesters, that solar energy is rendered and transduced within 24 hours by this incredible consortium of microbes from a life-threatening problem into a life-enhancing solution. Right? So that is what goes on inside a biodigester, inside the belly of the beast, inside the heart of the domestic, fire-breathing dragon. A dragon that, far from trying to slay, oh no, we should now rather turn into a house pet that can help save the kingdom rather than destroy it. Right? Want to know how to tame a dragon? Build a biodigester. Now that is chivalry.